the second session on structural analysis in GATE Training 2023. I am Amrita Varshini V, Assistant Professor, Department of Civil Engineering, VVCE, here today to discuss few problems on structural analysis which were asked before in previous examinations of GATE. So we had already solved few problems in the first session. Let us continue with the remaining problems. So the first problem for today is the number of independent equations to be satisfied for static equilibrium in a space structure is dash. I repeat, they are asking what is the number of independent equations that are satisfied, that are to be satisfied to say that particular framework is in static equilibrium, which is in space structure. So the hint here is the space structure. So they are saying the structure is where it is situated in space. Yes or no? Space. So what does that mean? Space means you need to consider how many axes? All the three axes, right? If it is in one singular plane, then you are considering only two axes. But here, since they are saying it as a space, you will be having how many axes? You will have three axes. So if this is your space structure, your space structure will somewhere be here. So this is one axis, this will be another axis, and you will also have z axis. Clear? X, y, and z. So they are saying that the structure is in all the three axes. Now, when a structure is in space, that means you need to consider three forces. Sum of all the forces in all the three directions should be 0, and moments in all the directions, all the three axis directions should also be 0 whenever you talk about space structure to be in a static equilibrium. So under force, there will be three forces. One is sigma f x equal to 0. That is, summation of all the forces in x direction should be 0. Second thing is sigma f y also should be 0. That is, summation of all the forces that are in y direction should also be 0. Then, since it is a space structure, sigma f, that is summation of all the forces that are acting in z direction, will also be 0. So this completes the forces in all the directions. Along with these forces, we also have moments, right? We will also have moments, that is sigma m at x should be 0, sigma m at y should be 0, sigma m at z should also be 0. So we have three moments, three force equations, which totally adds you to give 6 equations that needs to be satisfied to say that the structure which is in space is in static equilibrium. So these are the 6 equations that need to be satisfied. So what is the answer here? The answer is yes, the D, 6 is the correct answer. Clear with this? Let us move on with the second question. The second question says the force in member BD of the truss shown below is dash. You can see the options. Option says 4 kilonewton tension, 4 kilonewton compression, C 0, and D option is 12 kilonewton compression. Clear? So now look at the truss. The truss is, what kind of a truss is it? It is a cantilever truss, right? One end is fixed and the other end is free. Yes or no? Yes. So now you can make use of two different equations or two different methods to solve and get the force in member BD. So where is member BD? Member BD is here, right? So to find member force in member BD, you can either make use of method of joints, or what else do we have? Yes, it is method of sections, right? Now what happens if you make use of method of joints? You can easily start with joint C, as it has two unknown member forces and one known forces. So interest maximum of two unknown forces only can be solved, because we have only two equations, that is sigma f x equal to 0 and sigma f y equal to 0, right? We have only two equations that can be used to solve method in using method of joints, right? So if we solve joint C, we will obtain member in force BC, and then we will obtain member in force BD. Next we can move on to joint B, where you have two unknown forces, because BC is known right now, and then we also have 4 kilonewton, which is also known. So now what we can do, we can simply apply method of joints at B again, and we can find out member in force BD, which is what we need to find. Yes, but in examinations like GATE, you can not spare so much of time in solving all these things. In sometimes the trusses will be so simple, and like this particular question, since luckily there is no inclined force at B. Is there any inclined force? No. So all the forces are transferred collinearly, yes, to the same line. Whatever the force that is in transferring through the x direction will go to x. Whatever the force that is coming vertically will transfer vertically, right? So now, since we have only one vertical force at joint B, which is acting like a compressive force, right? It is coming towards the joint B, that is 4 kilonewton force. So now what we can do, since there is only one vertical force which is coming to the joint B, which is compressive in nature, in order for this truss to be in equilibrium, an equal force in the compressive direction should be given in the member BD in order for this stress to stay in equilibrium, right? So to counteract this 4 kilonewton force, we can give one compressive force, which is also 4 kilonewton in magnitude, and compression in nature. Why compression? Because this 4 kilonewton external load is also compressive in nature. So you can easily say that 4 kilonewton is the force that needs to be given in order for this stress to stay in equilibrium, and thus the member force in BD is 4 kilonewton compression only. So 4 kilonewton is the magnitude, right? And compression is the direction of the force in member BD. Now if you solve using method of joints or method of section, also you will get the same answer. You can cross check if you have time. So this is how you can easily find out what is the member in force BD. In questions like this, first think about what is the member, what are the forces acting on it, how easily you can find the member forces. Clear with this concept? Yeah? Okay. Now you know how to make use of, how to choose which method to adopt while solving the joints, right? So let us move on to next question, which is very interesting. Let's read out the question. For the loaded truss shown, determine the load in the member DL. So they are asking the load in member DL. Where is member DL? Member DL is here, right? Now, if you want to find the force in member DL, you can, as usual, you can adopt method of joints. If you go for method of joints, you need to start with joint I, then join J, then K, then L. Only then you will get DL, right? Yes or no? Which will be very tedious in nature, right? So this is not suitable for competitive exams. Now what we can do, we can think of the second method, that is method of sections. Now let us see what happens if we use method of sections. Method of sections, as you all know, you need to cut the truss into two parts in such a way that the member where you need to find the force will be exposed, so that you can find the member force in that particular member. So now you can cut the truss into two parts in this way. What happens if you cut the truss this way? This will be exposed, this force, and these three will be unknown. But again, if you take this particular section, if you take this particular section, you will have, it is nothing but a joint, right? Here the truss part is nothing but joint D. This is joint D, and this is one member, this is another member, and this is another member, right? So in this type also you are solving D, but to solve the joint D, what is the three unknowns? This is one unknown, this is another unknown, this is another unknown. So there are totally three unknowns. Now we have already discussed, we already know how many maximum unknowns can be solved in the truss. In 2D truss, you can only solve two unknowns, maximum of two unknowns. Since you have three unknowns, you cannot solve this equation, right? Can you solve this joint having three unknowns? No. For this joint to be solved, you need to make sure that at least one of the three unknowns are known before applying method of joints to joint D. Now, how to do that? Since now that we know that this cannot be adopted, what can we do? What can we do now? Think about what are the different solutions that we can take. Since at D we cannot adopt method of sections, we can solve by taking another section. You can say that instead of going like that, why can't we choose a section, cut the section like this, something like this. What happens if we cut the section something like this? We are just increasing the number of unknowns. Yes or no? Yeah. Here also there is one unknown. Here another unknown. Here another unknown. Already 3 are over. 4 and 5. You have to exit the truss to make a section, right? So however you take, this is not giving out the solution for us. Is it giving the solution? No. Then what to do? How to find the answer in a very quick way? Let me tell you, this frame, this truss looks more complicated, but we can find the answer for DL in just 2 steps. Just 2 steps. How to find out that? How can we do that? We can make use of both method of joints and method of sections. We can make use of both method of joints and sections to find out the member force in DL. How to do that? We know if we cut something like cut the section which cuts through DL, we are not getting the answer using method of section. So we also know that if we make use of method of joints for joint D, we can easily find out DL. But to do that, we need to make sure that one unknown should be known in prior. So we can try making DE member known. How can we make DE member known? We can simply adopt method of sections for this particular section by cutting the truss in this way. What happens if we cut the section in this way? We will have one unknown, two unknowns, three unknowns, right? There are totally 3 unknowns. Now we have made use of method of sections as the first part to make sure that we know DE force in prior, so that we can solve method of joints and find out the answer DL. Now what we can do? Look at the forces. I have just considered it to be compressive. Yeah, it can also be tension, but if whatever the assumption that we have made is wrong, we will definitely get negative as the sign in the force, which indicates that whatever the sign that we have considered direction is wrong. It needs to be changed. So let us assume it to be compression for as of now here, and here I have assumed it to be a tensile force. Now look at this joint at L. Now what happens here at joint L? The member force in EL is passing through L, right? And also the member force in KL is also passing through L. Yes, yes or no? Now, if we consider this part of the section, yeah, this part of the truss, we will forget this part. We will consider only right side of the section. We are considering this part of the section. As we have one load, external load here, we need to consider the external load to find out the member forces, right? Now, look at the joint L. If we take moment at L, the moment due to the force EL will be 0, and moment due to force KL will also be 0, right? Because both the forces are passing through L, and hence there is no perpendicular distance between joint L and the force, and thus these two unknowns, moment due to these two unknowns, will be 0 if we take moment at L, right? But what happens to this force? This force has some distance, perpendicular distance, and hence we can easily find out what is the member force in DE if we take moment at L. So now first is we will consider method of sections. We will cut the section and we will find sigma m at L equal to 0. What happens if we take sigma m at L equal to 0? Force due to EL into 0, right? Plus force due to LK into 0, right? Because there is no perpendicular distance between LK force as well as L, right? It is passing through the joint, right? So that is also 0. But we will have this force, 8 kilonewton force. It is making a clockwise moment, right? It is making a clockwise moment. So it is plus. So it is plus 8 multiplied by what is the distance? The distance between L and 8. L and 8 is 2 plus 2 plus 2, which is 6, right? 2 plus 2 plus 2 is 6, right? So now this is done. Next, we also have one unknown force, that is force in ED. Now look at this. How is it making? It is making anti-clockwise movement. We have considered the direction as this, and where the point is L, so it has to move down, and hence it is making an anti-clockwise movement. So anti-clockwise means negative, so it is S minus F E D multiplied by what is the distance, perpendicular distance between ED and L? It is 2 meter, right? It is 2 meter, which will be equated to 0. Now, since EL is 0, this term is 0, this term is also 0. Yeah, we are left out with only these two. Yes or no? Yeah. So if we find out what is, can we easily find out what is FED from this particular equation? We will have what is FED. That you need to find the answer and let me know what is the answer in the comment section. Clear? Now look at joint D now. We are done with method of joints. So second step is method of we are done with method of sections. Now we are doing method of joints. Where are we taking? We are considering joint D. We have three forces. Yes, one is FED. The other is what we need to find, that is FDL. What will be this angle? What will be this angle? This is a square, 2 meter and 2 meter. Thus, this angle will be 45 degree. You can also find the angle using tan theta. Okay. So, you know the angle. You know this force. Since we need to find FDL, we can simply make use of sigma Fx equal to 0. Resolve the force FDL into two parts. Consider FDL cos 45 plus, because it is acting right side direction, and minus whatever the answer we get. So in this equation, equate that to 0 and you will find what is FDL. Clear? I want you to solve this particular problem and tell me what is DL. So only 1 and 2. So totally we have made use of only 2 steps to find out this looks like a complicated question, but it is not. That is member force DL. So this is how you add both the method of joints and sections and find out the answer. So clear with this particular problem? I hope it is clear. Let us move on to next one. Okay, so this is an interesting question. You can see what is the question? It is related to degree of kinematic indeterminacy. Yeah, degree of kinematic indeterminacy. Let us read out the question. There is a beam. Okay, degree of kinematic indeterminacy of the given beam is dash. The options are 0, 3, 1 and 2. So what is kinematic indeterminacy? It is the total number of possible possible degrees of freedoms of all the joints. Now let us see what is dk. Is this a frame or a truss or a beam? It is a beam. So for beam, dk is nothing but 3j minus r plus n. So now what is j? J is nothing but number of joints. How many joints do we have here? One joint and another joint. So there are two joints. Clear? Now what is R? R is nothing but number of unknown reactions. So how many unknown reactions do we have? Here, what kind of a support is it? It is a roller support. So we have one unknown. What about this? It is a fixed support. We have one vertical, one horizontal, and one moment. So totally 1, 2, 3, 4. How many reactions do we have? We have 4 unknown reactions. Now, what is N? N is nothing but number of plastic hinges. How many plastic hinges do we have? None. So N is 0. What is dk? Dk is nothing but degree of kinematic indeterminacy. Okay. If you apply this equation, dk is equal to 3 multiplied by what is j? We have already found out. J is 2, right? Minus what is r? R is 4, right? Plus what is n? N is 0. So 3 2s are 6 minus 4. So dk for this particular beam is 2. So what is the answer? Answer is D, that is equal to 2. Clear with this? So this is the equation for beams and portal frames. Clear? Now, what is the equation for truss? For truss structures? for truss, dk is equal to 2j, okay, 2j minus r plus n. Okay, so since this is a beam, we are making use of this particular formula. This is only for truss. Okay, let us move on to the next thing. Okay, this is very important because this, if you know, it will make you to minimize the time in solving n number of equations. So what is this? This is the rule of zero member force. How can you identify the zero member forces? What is a zero member force? Whatever the members that have zero force is called as a zero member force. For that, if you have three members or if you have two members at one particular joint, there are two important rules that if you know, then you can clearly declare that that particular member is a zero member force, which will make you save you time in solving the problems in trusses. Okay, let us see what are those rules. Now first one is at a joint, if three members are meeting, okay, if three members are meeting and look at this, two members, just two members out of the three members are collinear. What do you mean by collinear? This, let us say this is one straight line. This is not a straight line. I'll write a straight line. Okay, I will write it here. So let us say this is a straight line and there are two forces. Let this be a joint, 1, 2, and let this be the third force. Clear? So how many forces are there at this joint? There are three member forces, right? Let us name it as 1, 2, and 3. Let this be 1, let this be 2, and let this be 3. Out of the three member forces at a joint, two members are collinear, that is, they are in the same line. Then the force in the third member, which is not in collinear, will always be 0. That means this is 0. When will this happen? When there is no extra inclined load or there inclined member. There are only three members, out of which two members are collinear in nature. Then only the third member will be 0. Clear? Now this is regarding three members. Okay, when the joint has three members. Now look at the second point. It says at a joint if two non-collinear members means something like this. At a joint where two non-collinear members, this is a joint and we have two non-collinear members are meeting with no external load, at that joint, where at that particular joint. At this joint there are two non-collinear members, then the forces in both the members will be 0. Then the forces in both the members will be 0. Only when there is no external load or a support at this particular joint. This joint should have only two member forces. There should not be any support reactions. There should not be any external force. If a joint has only two members that are non-collinear in nature, then only the member forces will be 0. This is for the two members and here it is for the three members. So these are the two important rules that will help you in solving the questions easily. Clear with these two rules? Yeah. This rule cannot be applied where this rule cannot be applied. Suppose if there is a support, no, then it cannot be applied. Or if there is an external load, then also it cannot be applied. Only if there is no external loads or supports at this joint, except only the three member forces, only then this will be used. Clear? Same thing happens to two members also. If suppose let us say there is this support, no, it cannot be used. If there is a load, no, this cannot be used. Clear? When you apply the rule and when you are not supposed to apply the load. So this, we will keep this in mind and we will solve the questions. Clear with this? Yes? Yes or no? Let us move on to the first question. Now I want you to answer how many zero force members are there in the truss shown. So this truss has n number of members, right? How many members are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 members. How many members are there? 21 members are there. Now tell me, out of these 21 members, yeah, out of these 21 members, how many member forces are zero? How many member forces are zero? Now let us look at the joint one by one. Let us look at the joint A. How many unknowns are here? This is a roller support, so it will have one unknown. Yeah, 1, 2, 3. There are three forces, but no two members are collinear. Hence, you cannot apply the first point, right? So these three cannot be zero member forces. Clear? Okay. Now let us move on to joint B. So let us move on to, so this is not 0. This is also not 0. This is also not 0. Okay. So now let us move to joint B. Joint B has 1, 2, and 3. Yeah. So we can think of point 1 in the previous slide. 3 members. The next thing that needs to be satisfied is two of the members should be collinear. Are the two members collinear? Yes. We have AB and BC collinear in nature. Yes, we do not have any support at B. We do not have any external load at B. We have only three members, out of which two members are collinear in nature, and thus point 1 can be applied, which means that the third member force will be 0. Which is the third member force? The member that is not collinear in that particular joint. So these two are collinear and this is not, and hence this is the third force, and thus this is 1, 0 force. Clear? So since this is not a 0 force, this is also not a 0 force. This force will be transferred, right? Yeah. Now let us move on to joint C. It has 1, 2, 3, 4, 5. Okay. Now since it has 5 joints, we cannot use both the rules. This is skipped. Now let us move on to next one, that is D. Look at D. Now if you look at D, we have three forces. Again, it is similar to this triangle. Yeah, there is no support, there is no external load, hence there is two collinear force, and the third force is DJ. Again, this will be the zero member force, right? This is a three member force, two are collinear, there is no support, there is no external load, and hence this is a zero member force. Okay, we have already got two. Maximum option given here is 3. Let us see if we have 3 or more than 3, right? Okay. So next is joint E. Joint E has 1, 2, 3, 4, 5, 6, 7, right? 2 at the hinges, because this is a hinge to support. 1, 2, 3, 4, 5, 6. This cannot be, rule cannot be applied here. Let's move on. Again, you have 1, 2, 3, 4. Can this be applied? No. Let's move on to G now. Now look at G. G has two forces. So we need to think about the second point. What does the second point say? If there are two non-collinear forces, yes, there is no collinear forces. The two members are non-collinear in nature. Okay, if that is the case and there is no support, there is no load, then both the members will be zero member forces. Yeah, 1, 2, both the members will be zero member forces, right? Okay, we have 1, 2, 3 and 4 zero member forces. So now let's move on to joint L. We have 1, 2, 3, 4. Again, this cannot be used, so skip. 1, 2, 3, 4. There is no rule for 4 members at a joint. Skip. Joint J, 1, 2, 3, 4, 5. No member, no rule. Skip. And I, you have 1, 2, 3, 4. No rule again. We need to consider the external load also. Yeah. If there was no external load, this could have been zero member force, right? But since there is an external load, this cannot be zero. Look at H, 1, 2, 3, 4. Again, this cannot be zero member force. Clear? So now how many zero member force we have? 1, 2, 3 and 4. That is BH is 1, DJ is second one, FG is third, and sorry, yeah, FG and GL. So there are 4 zero member forces. Clear? So there are 4 member forces. Unfortunately, the option given is wrong. The correct answer is, what is the correct answer? 4. Clear? Easy? So even if a complex stress is given, you can easily find out how many zero member forces are there. Eventually, you can find out the answer quickly. Okay? Okay. So the next question that we have here is number of zero force members in the truss subjected to a force as shown in the figure. So they are asking you what is the number of okay, they have already mentioned this as 0 and 0. In question they won't be giving you the members with the 0 indication. Okay, number of zero force members are to be found in this particular small truss that is subjected to force as shown in the figure. So now it is subjected to force at C, right? And we have 2 supports. Now, how to find out the zero forces? Look at the joint C. At joint C, we get member CB. We get member CB as 0 member force because the load is acting in horizontal direction and no load is in the direction of CB. Correct? There is a load acting at C in the horizontal direction. That means member force DC and the external load C will be a collinear force, and this will be the third force. Rule number 1 that will be applied to get the CB as 0. Okay, clear? Yes? Yes or no? Yeah. So now look at the second member, that is AB. Now, if you look at the joints A and B, both the joints A and joint B, they do not move relative to each other. Yes or no? They do not move relative to each other because we have a hinged support. We have a hinged support. That means AB has no change in length, right? There is no change in length in AB. So in member AB, no change in length. Why is it so? Because A and B joints do not move relative to each other. Clear? So because of this, when there is no change in length, there will be no strain. What is strain? Change in length by original length. Yes or no? When this is 0, automatically strain will be 0, right? So strain, when there is no strain, there will be no force. Okay. So therefore, even in member AB, the forces will be 0. So now tell me, what is the answer? What is the answer? Yes, it is option C. Is there any other force? No. Again at D we have 1, 2 and 3, which will not be a 0 member force, because you cannot apply rule number 1 or rule number 2. Again at A you cannot apply rule number 1 or 2 to find out A, D, because since there is a hinged support, there will be a force in member A, D. Clear with that? Yes. So now, since there is no force, we will have only 2 members that are having 0 forces. Okay, let us stop here. We will continue in the next session with few more problems on structural analysis. Thank you.